You are listening to the AI World Podcast, your trusted source for the latest innovations, insights, and trends in artificial intelligence, blockchain, fintech, and decentralized technologies. Each episode features expert interviews, engaging discussions, and in-depth analysis of how AI transforms industries worldwide. Stay ahead of the curve with the latest articles and exclusive reports from the AI World Journal, covering everything from emerging technologies to industry breakthroughs. For more news, global events, and access to AI World Society circle gatherings, visit us at aiworld.tv. Don't forget to subscribe to stay informed, stay connected, and be part of the AI revolution with AI World Lounge. Thank you for listening.
All right, welcome back to the deep dive. It is February 12th, 2026. And I have to say, looking at the tech headlines this morning, it feels like we're kind of stuck in a loop.
It does a bit, doesn't it?
Yeah, we've got new model updates, faster processors, chatbots with, I swear, more personality than my high school drama teacher. The whole world is still obsessing over the mind of the machine.
Well, it's the shiny object syndrome. We love looking at the software because that's where the magic trick happens. It feels like alchemy.
Right. But today we're doing something a little different. We're actually going to ignore the code. We're ignoring the personality updates. We're looking at the wall.
The actual wall.
Literally the socket in the wall. Because according to this special report we have here from AI World Journal, the entire industry is about to slam into a concrete wall at full speed.
And it's a wall made of copper wires, transformers, and just a lot of heat. We're doing a deep dive into the energy equation.
This report is titled The Energy Equation: Why Power is the Critical Bottleneck for the AI Boom. And I'll be honest, when I first saw this title, I thought, okay, utility bills are going up, kind of boring. But reading through this, it feels less like an accounting problem and more like a crisis management situation.
It is a crisis,
yeah.
And it's a silent one. For the last 5 years, or really since the whole generative boom started, the narrative was about scarcity of silicon.
Oh, yeah.
We just couldn't get enough chips. You couldn't buy a GPU to save your life.
I remember trying to buy a car in 2022 and being told it would take a year because of the chips for the dashboard. It was a complete nightmare.
Exactly. But this report argues that the era of silicon scarcity is, well, it's effectively over. The supply chain's caught up. We built the fabs. Now we are entering the era of grid strain.
Grid strain.
The bottleneck has moved from the computer itself to the power plant that feeds it. And unlike building a chip factory, you cannot just spin up a new power grid in 18 months.
That's the part that really stuck with me. You can ship a microchip overnight. You can't ship a power plant. So, okay, let's get into the why here. Because my intuition, and I think the intuition of most listeners, is that technology gets more efficient over time.
Right, it should.
My phone battery lasts longer today than it did 5 years ago. My LED bulbs use way less power than the old incandescent ones. Why is AI suddenly threatening to melt down the grid?
It's a great question, and to answer it, we have to get a bit technical about how these systems actually work. The report highlights this consensus forming among tech executives. Reliable energy is the new gold.
The new gold.
But to understand the drain, you have to distinguish between two specific terms: training and inference.
Okay, I see these words thrown around constantly in the industry press. Training and inference. Give us the breakdown. What's the actual difference in terms of, the electric bill?
Think of training as the education phase. This is when the AI is in the lab, it's reading the entire internet, learning patterns, figuring out how to speak English or, Python.
Yeah.
That involves tens of thousands of specialized processors running at 100% capacity, 247, for months on end. It is a massive, concentrated spike of energy consumption. It's like launching a rocket.
Okay, so that's the big boom. That's the Manhattan Project phase where they build the brain.
That's the boom. But once the rocket is in orbit, or once the model is finished, you release it to the public. That's inference.
Inference.
Inference is what happens every single time you use the bot. You ask a question, and the model infers the answer based on its training.
So me asking for a recipe for lasagna is an inference event. Me asking it to debug my code is an inference event.
Correct. And here's the trap. Training is a one-time cost, a huge one, don't get me wrong, but it ends. Inference is forever. And as these tools integrate into our phones, our cars, our word processors, the volume of inference is just exploding. The report explicitly warns that while training grabs all the headlines, Inference is the looming physical constraint.
Because there are millions of us doing it at the same time.
Billions, eventually. And the report gives a chilling detail here regarding the type of inference. It says, quote, every time a user generates an image, energy is consumed. That sounds obvious, but you have to look at the math.
Okay.
Generating a text summary is relatively cheap, but we are moving toward real-time video generation.
Right, the multimodal stuff where it's not just text anymore.
Multimodal. That's the buzzword. So if you ask an agent to generate a 4K video clip or hold a spoken conversation where it creates audio in real time, the energy cost per interaction doesn't just double, it skyrockets. The report compares it to the difference between sending a text message and streaming a movie.
Wow.
But the movie is being rendered from scratch, pixel by pixel, just for you, instantly.
And we're trying to run that on a power grid that was, in a lot of places, built in the 1970s.
A grid that changes linearly while the demand is scaling exponentially. It's a mismatch of physics.
The source material draws a parallel to the semiconductor shortage we were just talking about, but it points out a really key difference. When we ran out of chips, the solution was build more fabs.
Right.
It was expensive, but it was a clear path. It was an engineering problem.
Yeah, if you have the money, you can build a factory.
But this energy thing, this feels more like a geography problem.
It is. The report notes that you can have the most advanced data center in the world filled with the fastest chips that, say, Positron or NVIDIA can make. But if the local utility company says, sorry, we can't hook you up to the gigawatt line for another 5 years because we don't have the transmission capacity, then your billion-dollar facility is just a very expensive warehouse.
Just paperweights in the desert.
Essentially. And this determines where AI can be built. We're seeing a shift where tech companies aren't looking for the place with the best tax breaks anymore. They're looking for the place with the excess voltage.
So if electricity is the bottleneck, that usually means there's a massive pile of money waiting for whoever can fix it, or at least whoever can make the chips stop eating so much power.
Tokens per watt.
Tokens per watt. I saw that in the report. Is that the new metric everyone's chasing?
It's the efficiency metric investors are obsessed with. A token is basically a piece of a word. It's the unit of currency for AI processing. Investors want to know, how much thinking can this chip do for every joule of energy I feed it?
Which brings us to one of the companies the AI World Journal highlights specifically, Positron AI.
Positron is the darling of this report, absolutely.
They really are. They just secured $230 million in Series B funding. That pushes them into unicorn territory valuation over $1 billion.
Right.
But what really caught my eye wasn't the amount of money, it was who gave it to them.
The cap table tells the whole story.
It was co-led by Arena Private Wealth, and
Jump trading.
Jump Trading. Now, wait a minute. I know Jump Trading. Those are high-frequency finance guys. They trade stocks in microseconds. Why on earth are they investing in an AI hardware company? Are they trying to pivot or something?
No, they aren't pivoting. This is where the energy equation gets really interesting. For a firm like Jump, speed is everything. But in computing, heat is the enemy of speed. If your chip gets too hot, it throttles.
It slows itself down.
It slows down to prevent damage.
So for them, efficiency isn't just about saving on the electric bill. It's about performance consistency.
Exactly. If Positron can build a chip that runs cooler and more efficiently, it can run faster for longer periods without, melting the server rack. And the report notes that Jump isn't just an investor, they're a customer. That signals that the financial sector, which creates these massive amounts of data, is desperate for infrastructure that is high performance but thermally manageable.
Okay, so let's get under the hood. What is Positron actually doing? Is it just a better microchip? Because, everyone claims to have a better chip.
It's not just the chip, it's the architecture. The report describes it as memory-centric inference.
Memory-centric. Okay, break that down for us. Why does memory matter for energy?
So in a traditional computer architecture, what we call the von Neumann architecture, you got the processor over here, and the memory, where the data lives, is over there. To do a calculation, the processor has to reach out to the memory, grab the data, bring it all the way back, do the math, and then send the result back.
So it's a commute. Every single time it wants to think, it has to drive to work.
It's a commute. And that commute costs energy. In fact, for modern AI, simply moving the data back and forth burns significantly more energy than actually doing the calculation. It's a classic problem called the von Neumann bottleneck. Positron's Atlas platform and their Asimov silicon are designed to eliminate that commute.
So the memory and the processor they're roommates.
Essentially merged. They are trying to keep the data as close to the computation as possible, specifically for that inference stage. They want to make the deployment of AI drastically cheaper.
Which makes sense. If you want to put a smart assistant in every car and every toaster, you can't have a supercomputer running in the background for each one. The battery would die in 5 minutes.
Precisely. If they can crack the code on tokens per watt, they win the infrastructure war.
But, and there's always a but in these reports, at the exact same time that positron is trying to make things leaner and more efficient, we have other companies who seem determined to use up every single spare electron we have.
The Jevons paradox.
Is that what that is? I've heard that term before.
It's a classic economic theory. The Jevons paradox is what happens when technological progress increases the efficiency with which a resource is used, but the rate of consumption of that resource rises instead of falls.
So we make cars more fuel efficient and then people just drive way more, so we end up burning more gas anyway?
Exactly. Efficiency drives consumption. And the gas guzzler in this report is 11 Labs.
Let's talk about them. 11 Labs just closed a massive $500 million funding round led by Sequoia Capital. They're valued at $11 billion now.
With backing from Andreessen Horowitz and IconIQ, these are the titans of venture capital.
But unlike positron, 11 Labs isn't pitching efficiency. They are pitching capability. They're pitching more.
Right. They started with voice, which was already impressive enough. But the report says they're using this war chest to go multimodal.
There's that word again? Multimodal.
It means integrating everything. Imagine an AI that doesn't just read text. It listens to your voice, it watches your webcam video to see your facial expressions, interprets the context of your room, and then responds with its own generated video of a realistic avatar speaking to you all in real time.
The future of artificial intelligence is unfolding, and it's happening at AI World Week, the flagship global event for innovation, collaboration, and transformation. This flagship global AI event is designed to connect visionary leaders, trailblazing entrepreneurs, and influential thinkers to explore the endless possibilities of AI. Experience groundbreaking technology that redefines industries and inspires progress. Join thought-provoking discussions on ethical AI, digital equity, and the transformative role of technology in our world. Build meaningful connections that catalyze innovation and drive impact. AI World Week is powered by AI World Society, a global movement dedicated to advancing AI responsibly and ensuring it serves humanity. Together, we're shaping a smarter, more inclusive, and equitable future. Continue your journey beyond the event with the AI World Journal, offering expert insights, in-depth analysis, and the latest trends shaping the AI landscape. This is your opportunity to lead, to innovate, and to transform the world with AI. AI World Week. We invite you to join us and embrace the AI revolution.
Sounds incredible from a user experience standpoint. It's basically the Star Trek computer.
It is science fiction coming to life, but the report explicitly calls this computationally expensive. We are in a race. On one side, you have positron trying to lower the energy cost per token.
Right.
On the other side, you have 11 Labs creating models that require exponentially more tokens to perform these incredible magic tricks.
It's like we're building better, more efficient engines, but we're putting them in tanks that get heavier and heavier every single year.
That is the perfect analogy. The software is becoming heavier, just as the hardware tries to get lighter. And the question the AI World Journal poses is, which curve is steeper? Is the efficiency improving faster than the demand is growing?
And based on this report, what's the verdict?
Right now, demand is winning. The hunger for power is outpacing the savings.
Which brings us back to the physical world, because if the software keeps getting heavier, the data centers themselves have to change. You can't just run these multimodal beasts on the same server rack you used for email hosting in 2015.
Oh no, you absolutely cannot. And this is where the report dives into the infrastructure of heat. It mentions a rapid shift toward liquid cooling systems.
Liquid cooling. I've seen pictures of this. It looks like a science experiment. Are they really dunking the servers in fluid?
Basically, yes. Traditional air conditioning, just blowing cold air over hot chips, it isn't enough anymore. The density of these AI racks is so high, they generate heat like a toaster oven. If you tried to cool them with air, the fans would sound like a jet engine, and it still wouldn't work. because they're moving to dielectric liquid cooling to pull the heat away directly.
So the cloud is actually a building full of boiling liquid and humming wires. It's not fluffy at all.
Not at all. And it's getting bigger. The report uses the term AI factories. I like that term because it strips away the digital illusion. We are manufacturing intelligence, and that requires industrial-grade utilities.
So if you are a tech giant, a Google, Microsoft and Amazon, your strategy has to shift. You aren't just hiring the best coders anymore.
No. You're hiring electrical engineers, civil engineers, and you're negotiating 20-year contracts with utility providers. This leads to what the report calls the new competitive moat.
The moat. Usually that's your secret sauce, right? Your proprietary algorithm, your user data.
The report argues that the algorithm is becoming a commodity. Everyone has a smart model now. You can download open source models that are incredibly powerful. The real note is, can you actually power it? Do you have the juice?
That's a wild shift. It's like saying the best car company isn't the one with the fastest engine, but the one that owns all the gas stations.
Or the one that can guarantee the gas station is open. We are seeing tech giants racing to decouple growth from exponential energy consumption. That is the holy grail. Can we grow the intelligence without growing the electric bill at the same speed?
The report calls this intersection of AI and energy one of the most significant economic opportunities of the modern era. That is a bold claim.
It is, but think about the scale. If electricity is the bottleneck, then whoever solves that bottleneck controls the speed of the future, whether that's through, say, small modular nuclear reactors, better batteries, or just really, really efficient chips like positron is trying to build.
It also changes the geopolitical map, doesn't it, if geography matters again?
Completely. If you're a state or a country with cheap, abundant, reliable power, maybe you have a lot of hydro or geothermal, you suddenly become the Silicon Valley of 2030. You don't need to be in San Francisco. You need to be near the dam.
Physical reality is winning.
A cloud needs a ground, and that ground needs a power plant.
So let's zoom out for the listener. We've gone from code to chips, and now we're staring at the power grid itself. What is the big takeaway here? Why should the person listening to this on their commute care about liquid cooling?
I think the big takeaway is that we need to stop thinking of AI as this ethereal, free resource. It feels free because it's on a screen and, it often costs just a few dollars a month. But it is heavy, it is hot, and it is hungry. The report has this great line. Artificial intelligence holds the key to unlocking the next era of human potential, but that key is forged in physical infrastructure.
Forged in physical infrastructure.
It reminds us that there is a cost. The trajectory of our digital world is now locked together with the realities of energy production. We can't code our way out of a power shortage. We have to build our way out of it.
It definitely changes how I look at these tools. When I'm asking a bot to rewrite an email 5 different times just to see which one I like best, I'm burning real resources.
You are participating in a massive energy event.
I want to leave the listeners with a thought here, something that popped into my head while reading the section on scarcity. We've established that energy is the hard cap. It's the wall.
Go on.
Well, usually in our economy, when something is scarce, we ration it by price. If it's rare, it's expensive. But with power, it's also about availability. The grid either works or it doesn't. If the grid is overloaded, the lights go out. So here's the question. If energy availability becomes the ultimate limit on artificial intelligence, will we see a future where intelligence is rationed?
Rationed how?
Like, not just by who can afford the subscription, but literally, physically rationed. Sorry, you can't use the smart model today. The grid is at capacity.
That is a fascinating, slightly dystopian thought. Brownouts for brains.
Exactly. Maybe the free users get the dumb model that consumes fewer watts, and only the premium enterprise users get the high-voltage thinking.
It's entirely possible. If the grid can't handle the load, the smartest tools might be reserved for the highest priority tasks. We might have to choose. Do we use the power to run the air conditioner? Or to run the AI that figures out how to fix the air conditioner?
Just something to think about the next time you see that little thinking bubble pop up on your screen. It's not just thinking, it's burning.
It certainly is.
Thanks for joining us on this deep dive into the energy equation. We'll catch you on the next one. Take care of your batteries.